Yeah, so solving this equation, ideas, divide, somebody said divide by 6. Any other ideas? What sort of equation is it? Quadratic equation. How do you know it's a quadratic equation? X squared in it, yeah. How many solutions? 2. Right, there's 2 solutions to this thing, so that's one thing. What might I do to get the solution? Yeah, that wouldn't really help because I've still got an x in there, haven't I? I can see what you're thinking, square root both sides to get x on its own, but x is on both sides. What might we do? Sort of thing we were thinking about last week. Move them all to one side, so what would you do? Remember what we were talking about last week? The right-hand side must be 0. So we make the right-hand side 0. Now what do we do? How? No, we can't add those because one's x squared and one's x, so we can only add them if they're exactly the same. I could add x squared to another x squared or an x to an x, but I can't add those. We factorise. What does that mean? Sorry? Brackets, yeah. Well, take an x outside the brackets because it's common to both terms. What would I be left with inside the bracket? Right. Now the fact that the right-hand side is 0 comes into its own, doesn't it, Dan? Because I can now write down the answers. Because the right-hand side is 0, give me what possible answer for x? 6, x equals, sorry? Not minus 6. Well, not always positive, but the idea is that this bracket must be 0. Yeah, so therefore in this case x would be 6. Yeah. What's the other possibility, Dan? Always 2 solutions, as James said. Naught. Right? If x is naught, it doesn't matter what is end up here, it gets minus 6. Nothing times minus 6 is nothing. So x equals 6 or 0. Those are my 2 solutions. Okay? And that's the sort of thing we were doing last week. A health warning on this. Okay? If you don't recognize it's a quadratic equation and you're faced with this to start off with, let's look at this again. X squared equals 6x. That first equation that I gave you, if you're not careful, you think, and this is what I was half expecting somebody to do, let's divide both sides by x. If I divide both sides by x, what happens? Right, done. But unfortunately, I've missed one of the solutions. Okay? There's always 2 solutions in quadratic equations. I might not be interested in the fact that x could also be 0, but by dividing by the thing we're after, x, you run that risk of losing one of the solutions. And that's a general error, okay? A general thing that you don't do. If I'm after x, don't divide both sides by x because that gets rid of one of the possible solutions. It gives us one of them, but not the other, okay? So be careful here. Okay. I just jotted one down here. How do you solve that? to get it on the other side. No, don't do that. It's a quadratic. It's a quadratic, Greg, because no, it's got an x squared term. If we're going to solve a quadratic, we must make the right-hand side 0. So the last thing you do is move everything over to the right-hand side, okay? So it's in the right form to solve it. And do you remember last week we were looking at factorising as one method? Just solving it if there was no x term in there was the other method. Bearing in mind that when we square root, we get 2 roots. The third method was the formula method. Oh yeah, the quadratic formula method. Anybody remember the quadratic formula? All over 2a. Well remembered. Well remembered, okay? What are a, b and c? So in this particular case, a equals, in this particular case, a equals, no, the number in front of x squared, which is, no, because if it was 0, it would be nothing. So it would be 1. b equals -6, and c equals 8. Get your calculators out, calculate the values of x. Or 2 possible answers. There's a shortcut to solving this. We can use a quadratic formula and we end up with x equals 2 or 4. However, this shortcut is worth thinking about in some cases, and it's something that we need to know about because it really comes in useful when we look at some integration methods involving partial fractions, and also when we get onto the 3rd year or 2nd year when we start talking about electronic circuits, when we use these things called Laplace transforms to solve some equations, and they involve using quadratics in this sort of way. So, useful thing to know. Expand this out for me. Multiply out the brackets. What do you get? Right. Yeah, okay. So you got me there very quickly. X times x, x squared, minus 4x, minus 2x, minus 2 times minus 4 is plus 8. And if I combine these two, I get x squared minus 4x minus 2x is minus 6x plus 8. As Warren says, we get back to the one we had at the start. Okay. However, what do we do to do that? If you notice this, look, I have multiplied minus 2 and minus 4 to get 8, and I've added minus 2 to minus 4 to get minus 6. So if I want to solve something like this quadratic equation, x squared minus 6x plus 8 equals 0, I try and factorise. Solve x squared minus 6x plus 8 equals 0 by factorisation. It's called, by factorisation, which is the last method we want to look at. So there's lots of different ways of solving quadratic equations depending on the type of quadratic. This is a special case because it only works for nice easy examples that easily factorise. If this doesn't factorise easily, which is why I made sure I picked one that does work, we would use the quadratic formula. But there is a point to this, as I've said already. It's to do with what we're coming on to later on in the course. So by factorisation I mean I do this. I put a couple of brackets down. And I know that I've got x squared, so I can put x and x at the beginning of the brackets, because x times x gives me my x squared. It also works if I've got a number in front of this, like a 2 or a 4 or something. I can also attempt to factorise, but it gets a bit more complicated then. I'm not going to worry about that at this step. So let's just leave it at this. Now what I do is I think of two numbers, as was implied when we looked at how it worked out when we expanded. We look back to this again. I've got to think of two numbers that add together to give -6, which is here, and multiply together to give 8. So I go to it and I think, right, can I think of two numbers that add together to give -6 and multiply together to give +8? I'll focus on the 8 because there's only a certain combination of numbers that will multiply to give 8. If there's any number that will add to give -6, there's an infinite number of combinations. So focus on the 8. 8 times 1 is 8. 4 times 2 is 8. Those are the only combinations, okay? I could have positive 8 times positive 1 and positive 4 times positive 2 to get 8, or I could have -8 times -1 and -4 times -2, couldn't I? So those are all the combinations. Which one of those combinations adds up to give -6, -4 and -2? So -4, -2 goes inside the brackets. Okay? And now, as before, when we said the right-hand side must be 0, we can see why that's important, because that means that either this bracket is 0 or that bracket is 0. What value would x have for this first bracket to be 0? 4. What value would x have for the second bracket to be 0? So x equals 4 over 2. Done. Okay? I don't have to go through the process of using the quadratic formula. If it factorizes, we call it factorization by inspection, by just looking at it. Okay? And so sometimes you can do that with these quadratic equations. It's worth just looking at it and asking yourself, does it factorize? And if it's not easy and you can't see it straight away, don't spend too long on it, because by then you could have used the quadratic formula. Okay? But sometimes it's useful. Certainly the idea is useful. And in fact, it's an expansion of this idea of factorization that leads to the quadratic formula. It's called the perfect square method, but we'll come to that another day. Okay.